Please subscribe and you can download this code from description below. In multi-objective optimization problems, the Pareto front represents a set of solutions where none can be improved without degrading at least one objective. Python's DEAP, Distributed Evolutionary Algorithms in Python, is a powerful framework for implementing evolutionary algorithms, including multi-objective optimization using its tools module. This tutorial will guide you through the process of using DEAP to get the Pareto front for every generation in a multi-objective optimization problem. We'll provide a code example to demonstrate how to achieve this. To follow this tutorial, you'll need to have Python and DEAP installed on your system. You can install DEAP using pip. Let's consider an example of a simple multi-objective optimization problem. We'll optimize two objectives, maximizing x and y, which can be any function you wish to optimize. Here's an example code that uses DEAP to get the Pareto front for every generation. This example demonstrates how to use DEAP to get the Pareto front for every generation in a multi-objective optimization problem. You can modify the example by changing the evaluation function, number of objectives, or genetic algorithm parameters to suit your specific problem. The Pareto fronts obtained can be further analyzed to make decisions about the best trade-offs between conflicting objectives. ChatGPT. DEAP, Distributed Evolutionary Algorithms in Python, is a powerful framework for evolutionary algorithms in Python. It provides a flexible and extensible platform for creating and optimizing genetic algorithms. In this tutorial, we will focus on using DEAP to get the Pareto front for every generation of an evolutionary algorithm. Before we get started, make sure you have DEAP installed. You can install it using pip. You should also have a basic understanding of genetic algorithms and how DEAP works. If you are new to DEAP, I recommend reading some introductory materials on the subject. In multi-objective optimization problems, a Pareto front represents the set of solutions that are non-dominated by any other solution in the objective space. These solutions are considered optimal as they represent trade-offs between competing objectives. DEAP allows you to get the Pareto front for each generation of an evolutionary algorithm, which can help in visualizing the convergence and the quality of the solutions over time. For this tutorial, let's consider a simple multi-objective optimization problem where we want to minimize two objectives. In DEAP, you need to define the problem as a creator and individual class. Here's how you can do it. In this example, we create a fitness multi-class with two objectives to minimize, -1.0, -1.0. We also define an individual class that uses this fitness multi-class for its fitness. Next, you need to set up the DEAP toolbox, which includes operators like selection, mutation, and crossover. You'll also define the population and specify the evaluation function for your problem. Here's an example. To record the Pareto front for every generation, we need to create a custom statistics object that stores the Pareto front. We can then use this object in the algorithm to collect the Pareto fronts. Here's how you can create the Pareto front logger. Now, you can run the evolutionary algorithm and collect the Pareto front for every generation. Here's an example of running the NSGA2 algorithm for 50 generations. In this example, we use the EAMU plus lambda function from DEAP's algorithms module to run the NSGA2 algorithm. The Pareto fronts for each generation are stored in the Pareto_front_logger.Pareto_fronts list, which you can access and analyze. In this tutorial, you learned how to use DEAP to get the Pareto front for every generation of a multi-objective evolutionary algorithm. This information can help you analyze the convergence and quality of the solutions over time in multi-objective optimization problems. You can extend and adapt this approach to more complex problems and different algorithms. ChatGPT.